Hello, welcome to the Python programming series. And in the first video, we covered the installation of Python and the PyCharm IDE, along with some basic arithmetic operations. And from the arithmetic operations that we've seen, the addition, subtraction, multiplication, some exponential division, some floor division, and also finding the modulo or the reminders for some operations we send this one. If you didn't see the first video, you can click on the link on the top right, or you will find also the link in the description. Just set up your Python and the PyCharm ID, then come back. Today we will dive deeper into Python's data types, including the elemental and the complex data types, about variables, the conversion of type of data, different that from one to the other, and also about the functions. By the end of this video, you will have a strong understanding of how to work with different data types in Python, and also just to define your custom functions, and also you will know about how to use the built-in functions of. So I will start from the variables. So when we say a variable in Python, just this variable refers to the memory of the memory address in the data to in the computer to store our data. We will have some memory address, then we assign the name of some variables. That's called the variable. We assign a variable to the memory address, then on that memory address we store just our data. Then we can reference that data, and also we can manipulate within the program about the data. And when we say the variables, they are the common rules or the naming rules of these variables. The first thing, for the variable, that should start with a letter, or it should start with the underscore. There's two options. It should be a letter from A to Z, or it could be also an underscore. It can start with an underscore or the letters. Then the second one, the letter. I mean, the rest of the name that includes letters, the number, and also the underscore. We have three options. We could use letters, we could use number, we could use underscores. From these three of the data or the types, we can use only two of them to start, but we couldn't start the variable with a number, but we could use a letter or an underscore. And the next thing is just the variable names are case sensitive, so we should care about this one. They are case sensitive, which means if we see this one, let's say age, a with small, and age with a with capital, they are different variables actually in Python, so they are case sensitive. We should know also about this one. And the second one is there are some reserved key words in Python, like just for, while, if, and, or. There are others, you can just go and search for that one. So this reserved Python keywords, we couldn't use them as a variable in writing them. The common practice or the good practice in using variable, actually the variable name or the variables could be a single letter, or it could be also two or more than letters or number, and a combination between letter and a number, and it could be also a combination of an underscore and a letter. But the good practice in variables is the first one. It is a good practice to use a meaningful name. Let's say if I want to put some data on the computer memory about age of somebody, so I can say just a, which is some value, as from the examples you see here. I can say name, which is John. Now John is a string. That is the one that I want to put in the computer memory. So I give another variable. This name is just now the name for a variable. This is just a variable, and the equal sign in Python is just assigning a value to a variable. If I want, I can say just a, which is equals to name. I can use this one. I can use here the name. It's also possible. I can use a single letter to a variable, but now this a is not meaningful. So the good practice is to use a meaningful variable for the values. Then age 25, I can assign the first one is a string. I assign a string to a variable. Now assign an integer to a variable, which is age. The second is just when we have two or more names in the variable, it's a good practice to use underscore between these words or to separate the two words. Let's say if I want to put some first name or last name, I can use just first, then directly name, first name, but that's not readable. That's not good to read such data. So it is a good practice to use underscore between these names, just first, then underscore name. Or here, I have the total price, then I use an underscore between total and price. Now we will jump to the next point, which is the data types in Python. We divide these data types into two. The first one is just some elemental data types. The second is just complex data type. When I say this elemental, we will have integer, or which is just when we say an integer, that's a whole number without any decimal points, or it could be a float. A float is just a number with or a numeric value with decimal points. Then we will have a complex number, which is just real and complex. Then it could be also a string. When we say a string, this is just a sequence of characters enclosed in quotes. And the last one from the elemental is just a Boolean. Second, the last point is a Boolean. I will come to the complex data types. We will check this one with examples now. From the elemental data types, this, let's say x5, this is now a 5, 7 or something, just 10. These are the integer values. And when I say this one, the y, which is float, now 3.14, this is a float. I have decimal point. This decimal point, this is called the float data type. Here, for the complex data type, what we could do is put j for the complex part in Python. This is just to define a complex number. Now a 3 plus 2j, this is now a complex number. This is a complex number, third type. Or the string is just to put the sequence of characters in a quote. Now I put the hello world in a quote, in a double quote, and this is now a string. The data type for this sequence of characters with a double quote or inside a quote is called the string data type. The last one is just the Boolean. Boolean, when we say a Boolean data type, we represent two different values, which are true or false. This true or false, we call them as Boolean. Boolean is something, it has two values, true or false. That is just Boolean. Mostly we use this one for the logical operations or some comparisons, which has only two options. If I say, is it raining? The answer will be yes or no. In this case, we use the Boolean data types. So to check these data types, what we use is the Python has a built-in function which is called type. Now I have x. Okay, I will remove this one. Now x5. Then I will run this part from x. Now I have the value of x5, y, z, the string and the Boolean. And also I will check the data types for each of them. The data type for x, data type for y, data type for z, the data type for string x, which is the string for this one. Then is raining, that's true or false, that is just a Boolean. And so I will also check the data type for this one. So I will run this section. So in Python, as I show you in the first video, to run the script, you can use this run button here, the run or the play button, or you can right click and run. Now in this case, I can right click and I will run here. If I run this one, it runs the data types. I have the file name data type, but I want to only run the ones that I select. I don't want to run all the scripts. Sometimes you will have the file or the code which has 1,000 lines, but you want to run only 1 or 2 lines. In that case, what you do is just select the part or the section of the code that you want to run, then right click and click here execute selection in Python console. Sorry. So when I side this one, or I can use also the shortcut, just Alt plus Shift plus E. That's also the shortcut for this one. When I click here, it only runs this section. Then I will check the results. Now it runs this section, the one that I select. These are the line of codes that I select. It runs them, and I see the results. Now the first one is an integer. Now this is the class is integer. The second one is float, then complex. Now this one is just integer. This one is float. This is complex. Then this and two. This is a string, and the last one is Boolean. Now this is a string and the Boolean. So you can check the data types. You can check the data types using the built-in function of Python type. Type, then put the name of the variable. Now this variable x, this variable y, and they are the variables. Now put the variable type of the variable, then it gives the data type. This is the first thing. So now these are the elemental data types that we have in this case. Then the second point I want to discuss at this point is how we can convert the data types from one to the other. So the integer value 100 is assigned to the value of x. And the first thing is I want to check what is the type of x. Then if I want to change the integer value to float, what I could say is float, then put the name of the variable x. Now the data type for y should be what? Because now in this line of code, the second line of code does change the data type of x into float, then assign the float to the variable y. Then I check the type of y. Then again, in this line of code, it changes the data type of x into string. Then the string is assigned to the variable z, and the other one is just the Boolean. When we use Boolean, since we have two options for Boolean, the Boolean has two values, either true or false. If I want to say the Boolean value to true, I say just the Boolean of x that gives the Boolean true. And if I want the Boolean false, we say it's not bool. The not bool code, this one gives the false for the script. So I will now execute this line of code. Then we will check the results. Here you see I run from x100. Now I check the type of the data type, that is an integer. Then I change the integer to a float, then assign to the value of y, and I check the data type for y. It gives now float. Then after this one, I change the data type of x into string and assign the value to z. Then I check the data type for z, which gives the string. Then the last two options, I use just the bool of x, which gives the Boolean true value, and not bool of x, which gives the Boolean value of false. So when I check this one, the data type gives the value for this one is just true or false. So we can change the data type from one option to the other, from one data type to the other data type. But now we will come to the next point, which is the complex data types. When we see here the data types, we have two broad options or kind of categories. This is not just the basic thing. We have the elemental data types, which includes the integer, float, complex number, string, and Boolean. So using these different types, we could have some complex data types, which includes the list, tuple, the dictionary, and set. We have these different complex data types. We will come to these different data types one by one. Okay, now when I say the list, first thing is just the list. When I come to list, a list is just an ordered collection of items, some ordered collection of items which can be of different data types. It could be the same data type, or it could be different data types. The data types in is the elemental data types. Then the ordered collection of these data types of these different items in different items, which could be the same data type or different data type. That gives a list, and this list are the mu table, and The mutable means we can update the value, we can change, we can add new value, or we can delete one of the value or the that one. Okay, so as an example, let's say this is just some my list. If I say this one, this is just the name for the variable, the my list, then what we should use is the square bracket. Then in square bracket, we list our values. I can have an integer, I can have a float, or I can have also a string. I can add string in the string. So I'm just, I can say hello. This is just a list. I'm just listing with comma. I can add complex number if I want 3 plus 4j complex number. And I can have also the Boolean. I can have a Boolean true. Now, this is just a list. I have 1, 2, 3, 4, 5. 5 different items. I have 5 different items. These are an ordered collection. When we say ordered, which means just we can index each of them. The first one is just always 12. The second one is 3 point. The third one, and the fourth one, the last one. Then the second thing is it could be the same data type or it could be a different data type. Now, from my example here, I use different data types. I can check the data type for, I can print my list. Okay. Now, I have this list and I run the list. Here, you see, I run my list. I have a list, then it has these values. These are the values for the list. So if I want to know the first value from the list, only the first value from the list. This is just my list. I print my list. From my list, I can index the value. I can say 0, which means the first one. In indexing, it starts from 0, then it's just the first one. Now, if I run this line, that should only print 12. You see here now, this one only prints 12. First time when I print my list, it has all of the items. Now I could index each one, which means just this is an ordered collection. I can say the first one, the second one, the third one, that is an ordered collection of items. And it has a different data types, would be. Then I can check also the type of data for this one. Now I can say just type, the type of this one, the data type for the first element. I can check the data type, which should be an integer. This one, for this one, I check, run this. Now this is an integer. I can check for what will be the first one. Then the first one means just second from the list, which gives float, because that's now with a decimal point. Then the third one will be, which is the second from the index, or the third item. That is what? A string. The last one, this is a complex, this is also a Boolean. So the point is we can use different data types in a list, and that is just a list of some items that we call the list, or the collection of items. That's a list. The next point we should discuss at this point is just the lists are the mutable, which means just we can change its content, we can update, we can add, or we can delete the contents of the lists. For this one, I have a list here, fruits, which includes apple, blueberry, banana, lemon, orange. I have just some examples for fruits. So I have the fruits list. Then the first point, I will print this fruit. And you will see the list of fruits, which is apple, blueberry, banana, lemon, and orange from the result. Just when I say run, I use always the shortcut, which is Alt plus the one that I show you previously, this one. just to execute the selection of the Python console, I used just Alt plus Shift plus E on the keyboard. That's why I didn't just click on the run button, or I didn't right click. Yeah. Now I run this one. Then the first point is this one, which is just updating the value. This is called the update. Updating the value, which is just now I update the first value, which is index 0, which means 0, which is the apple one. Now I change the first value to blackberry. I want to change the apple with a blackberry. Then what I could do is just give fruits, which is the name of the list, which is given here. That is the name of the list. Then this line of code size, just from the lists in fruit, named fruit, take the first item. The first item means from the index 0, then the index 0 and change with the blackberry, which is just the comment for this one. Now I will update this one and I will print again the list fruits. I will print this one. Now you see here, previously it was just apple, as we see here, that was an apple, blueberry, banana, lemon, and orange. Now after the update, it is just updated to blackberry. The apple is now changed with a blackberry, blueberry, banana, lemon, and orange. So we can update the value. That is the first thing what we do. The second one is we can remove or just delete some parts or just some of the elements or the items. Delete an item in the list. We can delete an item in the list, which means to remove an item in the list, what we should use is just write the name of the list, which is fruits, then put point, then after putting this point, then fruit point remove. The command is now just remove. We remove what? Then give the name of the item. The name of the item is just lemon. I don't want lemon, then I can delete lemon here. So if I run this section, it removes lemon and it gives, since it is updated already, we don't have apple, that is the blackberry, then the blueberry, the banana, and it removes this one in orange at the end. Now I can run this section. I can run this section and see the result. See, here it was just blackberry, blueberry, banana, lemon, and orange. Now on this line, the result shows here. This is just the blackberry, the blueberry, then the banana and orange. Now I don't have the lemon. The lemon is just removed in this list. So we can remove or just delete an item in a list. Just the list. Then the second one is just we can add a new value to a list. I have the list now. I remove and I have the list now, the blackberry, blueberry, banana, and orange. So if I want to add an avocado, I can append. The command for this one is just append or just add an item. I can add an item in the list. For this one, just dot append is the command that we use to change or to add a new value or a new item in a list. I can run also this one and see the results. Now it was just blackberry, blueberry, banana, and orange. Now it adds an avocado at the end, or it appends or it adds a new item to the list. Advantage for these lists is they are just flexible. We can have a fixed data types, or we can have a mixed data types or different data types. We can include integers, strings, float, complex number, or booleans in the list. That is, the flexibility is a good advantage for these lists. And the second one is we can add, remove, or we can modify the elements of the data. These are the advantages for this list data types. Before I go to the second point, I have some kind of an exercise for you. You can solve this one, and if you want, you can put them on the comments. That will be great if you put any comment. So the exercise will be just create a list of your favorite movies, and from these movies just then modify the list. The first thing, just by adding one new movie, then remove the one that you don't like from the list, at least one, and then print the final results at the end. Now I will move to the next complex data type, which is tuple. Now this tuple is kind of a similar thing, or it has a similar structure like list, but the difference, or one of the differences, it is a mutable. It is a mutable, which means we couldn't update, or we couldn't remove the value, we couldn't add, or we couldn't update the values for the list. It is kind of a permanent list. When we say tuple, it has some permanent values in this case. We have some example here. I have the coordinate for certain place, which is 52.52 and 13.4050, which are the latitude and the longitude of some position or some place. I assign the value, the first value, which should be the latitude for this one. Then I assign the latitude, first value to latitude, and I want to print the latitude. So I can run this section and check the results. Now it just prints, and the latitude is 52.52, 52.52. This is just the latitude, or the first option for this one. Then the second one, or the second point here, is we couldn't update, or we couldn't change, or it is not possible to change the contents of the table. So I want to check that one. Since I comment here, I will remove the comment actually. Then this is just something to update the coordinates of the first value to just 40.733. Then I will run this one, and I will show you that is just something, the error. Okay. Now here you see this has a syntax error, and it says the type of error is now the tuple object does not support the item on assignment, or just update. I couldn't assign to the value of a tuple because that is just something fixed or a constant value. So when we use tuples, just make sure you don't update, or you don't add or remove the part of the data. Okay, this is the second complex data type. Now I will move to the third one, which is called the dictionary. This is the third type of the complex data types. When we say a dictionary, this is just a dictionary and is an ordered collection, no indexing here. We couldn't say the first one, the second one, the second, the first, or third value. They are just the collection of the k and the value pairs. Previously, we have only the collection of values, or the collection of items in a tuple, and in a list we have only the collection of values. But in dictionary we have the collection of k with a value. We have some k's, then we assign a value for each of the k's. And since we have the k to identify the values, they are just unordered, which means just we don't have the indexing, the first index or the second index or the third one. We couldn't say that one. That is just unordered collection, and it has the pair of k and the values. Okay, in this case, each of the k is unique. We should have different k values, or the unique keys for. Then we assign the data to each of the keys, or we have some corresponding values for each of the IQs. Since these keys are a unique identifier for the value there should be, we couldn't use the same key for two different values. Or the kind of the syntax for the list, we use the square brackets. Then for tuples, we use the curly normal brackets. This the normal brackets. Then for the dictionary, we use the curly brackets. And in the curly bracket, we put the key. This is now the key, which is name. Then I have the value, which is just John. Now the key name, and which is associated with the value John, or just the value John is associated with the key name. Then the value 21, which is associated with the key age, and electrical engineering, which is just associated with the major, which is some kind of a data. I want to put some data for the student. Then to print out what will be the result for this one, I will print this one out. Since I have now different values here, okay, now I have the key in a student, then I use just the for loops to print this four of them or these three values. K for the K in the student, which is the student is now the dictionary. So it finds different Ks in the dictionary student, and in this case, it prints the key plus the values associated with the key. This one, student key. This one is just the value associated with each of the keys in the dictionary student. This line means just the value of the key, the value of the key, just since it is just for a key in student, the value of the key in the dictionary student, which is assigned with the key. So I will run this section. Actually, this is just what we call dictionary is this one. So I want to see the result for this one. I will run this section now. You see here now name, which is John, age 21, and major electrical engineering. Similar to that of the lists, we can update a dictionary. We can remove part of the dictionary and we can also add a new one. First thing is I want to add one value. I have here this list of values. Then I want to add the graduation year from the list. Since I used the name, age, and the major, but I don't have the graduation year. I want to add the graduation year. So with a graduation year key. Then use this one. I write the name of the dictionary, which is just student in this sense, then student, then I add the key for this one, like just name, age, or major. I add the key, which is just the graduation year, then assign the value to the key. Now I assign the year 2024 to the value. This is just this 2024 is the value, then I add this value to the dictionary K graduation year. Now it adds the graduation year. Now I will run this section and see the result. Previously we have name, age, and major. Now in this case we have name, age, major, and it adds the new value, the K value here. Graduation is year is the K and it adds 2024 as a value, and we add now this one to a dictionary. The dictionary is created. So we can append the dictionary. This is the first thing. The second value is we can also use to delete or to remove one of the values. For this purpose, we use the delete, DEL, the short form for delete. So we give the name of the key to delete, and also actually the delete removes the value related with the key. So from this list, now I want to remove this one. Age, delete, then the name of the dictionary, which is student, then I add the key that I want to delete. The key is 21. It's not important to add the value, so only giving the key. Now I will run this one and check whether the age is removed or not. We will run this one and check the result. Okay, yeah, now I run this. Here you see name, age, major, and graduation year. Now here I have name, major, and only graduation year. Already the age is removed, or that is just deleted. The advantages, one of the main advantages for this dictionary is we can just use this dictionary to count something related with some key value for counting some occurrences or how many times something occurred. So we give them key value and just we count the values, how many times it occurs. That gives some kind of the occurrence counting is would be done in a dictionary. And the second one is just we can use to store some personal attributes like name, age, address, or related stuffs. Then the other thing is just the flexibility. We can use the case and the values can be different data types or any data types. That's not fixed to some integer or some boolean or some string, but it could be whatever it is. We can use all of the elemental types of the data types in a dictionary, so it's flexible in that sense. So to see how we use this one to count occurrences to the I have one other example on this. I write a name here, just an item, which is now it as we see on the first complex data type. Since it is I have a list in a square bracket, they are just list. If it is just a normal bracket, that will be a tuple, but now since it is just a square bracket, it is a list. I have a list of some fruits. So I have apple, banana, then apple, orange, banana, and apple. So I want to count how many apples I have, how many banana I have, and how many orange I have from the list. Yeah, since this is just as example, I have 3 or 4, we can say, oh, I have 3 apples or 2 banana and 1 orange. But if I have thousand or millions of items in a list, it is difficult to count them manually. So we can use these dictionaries to count for giving some key values. Now the key will be apple, the first key, banana, second key, and the third key will be orange. I have 3 different keys. Then I have count. I have 3 apples, which means 3 is a value, an apple is a key. I have 2 banana, 2 is a value, and the banana is a key. And I have 1 orange, 1 is a value, orange is a key value. So the first thing, I initialize the dictionary. For initializing, since we say here on the previous, we use this curly brackets for a dictionary. So I give a name, a dictionary, and if I didn't put any value in the inside this curly bracket, that's called this initialization. I have the name for the dictionary. I give the name, and it's just kind of initialization. Open. So I initialize the dictionary here. This is just the initialization only with this curly bracket open and close. I don't have any value here. Then second one is just for an item in items, which means just items. The name items is the name of the list. So an item, when I call item in items, an item means since I have only 1, 2, 3, 4, 5, 6. I have 6 items in the list. So for an item means just the first item, second item, third item, fourth item, and so on. So for an item in items, then the thing is just now I want to count how many apples I have, how many bananas. So when I see the first apple, then it's for the counting. The thing is I want to update this count since it is just initialized. So what I could do for this one is they have some get attribute in Python. This is just a built-in function get. What I could do is just I can say get or I count. This an item count is the initialized dictionary name. An item count in square bracket, which is an item, let's say just apple for apple. If it is the first time, if it is just the first time, it takes an apple just one with that value. And if it is the second time or the third time, it adds 1 for each of them. It didn't assign. If it is the first time, it assigns 1 value or just 1 value for the item. If it is the second time, it adds 1, which is 2. The value will be updated and it just puts the key. Then finally, it prints the counts, which is just a dictionary in that sense. Then I will run this value and see what it looks like. Now it prints the item counts. Look here. Now, initially I was just initializing an empty dictionary, but now it has a value. It counts. I have apple 3 times, banana 2 times, and orange 1 time. And now I come to the last type of this complex data types, which is set. So when we say set, that is the last one. A set is just an unordered collection of the unique elements in this case. I have some collection of items, but they are not ordered. We don't care. That's just initial or we couldn't index them. And it only contains the unique elements, which means we couldn't repeat the same element 2 or 3 times in a set. So unlike lists, sets does not allow just duplicate elements. Like the mathematics set, we can do operations like union, intersection, and stuff in the sets in Python also. So let's say if I have this value, if I have my set 1, 2, 3, 4, 5, 5, 5. Now I duplicate 5 3 times. If I print the result for this one, for my list and my set, the result will only contain 1, 2, 3, 4, and 5. It just removes these 2 because they are duplicates for these 5. In a set, we use also these curly brackets, but in a dictionary, The sign is the same with the dictionary. We use these curly brackets, but in dictionary we have the k and we have the value. So we have the k and value pair. But in a set, we have only a list in a curly brackets, just a list in curly brackets. So that is the difference with the dictionary. So I can run this value. Then you see here now my set has these values, then I will print my set. Look here, when I print my set, it contains only 1 5. It just doesn't con it doesn't consider this to the extratus because there are some duplicates. Since it is a set, it doesn't care about the duplication, or it removes the duplicated elements and it only has these values. And the other thing, we can update a set like a list. It's possible to update, it's possible to remove. So to add, we in a set we use add. So in a list we use append. In a set we use add. To remove, we can say here just remove the same thing, the same content. In dictionary we use to remove what? Del, or delete. Just you should identify this case or the kind of operators for a set, for dictionary, for a list, or for a tuple. Actually, in a tuple we couldn't do that one. So for these three of them, you should remember these keywords or the key things. So this add is now the keyword to add some element. If I run this one, now it adds 6 to a list and I can print it again. Can print my set again. Now I will see 6 added next to 5 because already this is just added. I already run that one. Now you see, since 6 is added here on the set, now I have 6 added on the set. Okay, now I can change or add the value. Then the next point, I can remove also value. So if I want to remove 2, I can say just my set, which is the name of the set, then point, remove, then give the value directly. Then I run this one. Then now it removes the value. I will print my set. Then let's check this one. Look here. Now it was 1, 2, 3, 4, 5, 6, but now 2 is removed and I have 1, 3, 4, 5, and 6. So we can remove an item in a set. We can add an item in a set. The other thing is we can do like mathematics, we can do an intersection and union of a set. So I have one set. Look here. Now the set is this one. Just since it is just I add 6 and remove 5. Now my set is updated to this value 1, 3, 4, 5, and 6. Then I define a new set, which is just I define as another set, which is 4, 5, 6, and 7. Then I could do an intersection and a union. So if I want to define an intersection between my set and this new set or another set, I have two different names. So okay, first thing, let's print the another set. Now my set, the print for my set, I have 1, 3, 4, 5, and 6, and I have for the another set 4, 5, 6, and 7. So I want to the intersection between this set and this set, between this set and this set, between these two different sets. So okay, so to define the intersection, now I give a name intersection. Actually here, intersection which it gives, you could use a different name here. Actually, it's just the name. But this dot intersection is the keyword at this point to define the intersection between two sets. So I have my set point intersection with another set. So my set point intersection, then I give another set, which is the name of the second set. Or you can say if I have two sets, set A and set B, which means set A, if I have two different sets, the easier value is just set A point, then we give intersection with what? With another set B. This is just the syntax for intersection. This is the syntax for intersection. Then we assign the value to some variable. Now, in this case, I have, I have another set and I have my set. So I want an intersection between them. Then my set point intersection with the second set, which is another set. Then the value of this result, the value of the intersection between the two sets, I give or assign to the variable intersection. Now this intersection is just a variable. I want to put the intersection of the two results. Then I will run this one, the intersection, and I will print the result. So I could run this too. See, now I have the intersection. Look, I have set 1, 3, 4, 5, and 6. The second set is 4, 5, 6, and 7. The intersection will be 1, that's not common point. 3, that's not common point. I have 4 in both, so then 4 is 1. Then 5, then the last one is 6, that's common. 7 is not common. So the intersection is just 4, 5, and 6. The result is just 4, 5, and 6. So we can have an intersection between sets or a union between sets. Similarly, we just change the variable intersection with union. So the union between my set and another set. My set point union, then another set, which gives the union of the two sets, which means just I will have the result for this one. It includes everything, just removing the points which are duplicated. Then the union gives 1, because already I have 1 in the first set. 4, 3, 4, that's I have this one in the first set. Then 4, 5, 6, they are common in 7, that's I have on the last set. So in the union, it contains 1, 3, 4, 5, 6, and 7. So we can do the union, an intersection. This is just the operations like mathematics. Then I can have add values in the set. I can remove values in the set, or I can manipulate the values of the sets. And the key point here, compared with the list, in sets we couldn't have some duplicate items in the set. The set contains unique items, but in lists we can have some duplicate items in the list. That is the key point or the key difference between those two. Okay, now I will jump to the next point, which is the functions. So before I move to the functions, I have some kind of exercise for you for a set. So you can just practice with this exercise. The exercise is here. Just create a set of your favorite hobbies, then add one new hobby, then remove one of your hobbies, then finally print and see the final set of your hobbies. That will be an exercise for set. Okay, good. Now I will jump to the last point, which is just a function. Function, this is just a kind of block of code that performs some specific task. Functions help to break down the complex problems into smaller and usable piece of codes. Okay, in general for this one, when we say a function, the syntax for function is just I define function, which is called here. Okay, I will give you. Then the first is just def, which is to define the function. Then I give the function name. Okay, I have already the syntax here. This is just a definition, which is defining a function, which is the built-in keyword def to define the function, then give the name, then after the function name, put the parameters to use, put the parameters which are important for the function, then put your just code to execute the task. Just put your block of code here, that the block of code to perform a specific task. Then put those block of codes here, and finally return results. Return is also a keyword to return the results of the code into the function. I have the function here. Okay, now let's make it simple with example. Now the first thing goes here. I have the definition and I want to have some kind of block of code. This is just a simple function that I'm thinking to give a name, and it says hello and gives the name. So in this example, I use Bob as a name. So when I say hello and I call a function, then it says hello Bob. That is just the output that I'm expecting at this point. So how I define this function is just I define the function and I give the name greeting for the function. This is just my definition for the function, I define a function as greeting. Then the parameter here is, since just I want to say just hello Bob, hello John, hello, just give the name, then the name is a parameter at this point. Then in bracket I put the parameter name as name, which is just a parameter for the function greet. Then since it is just hello, I want to write some codes to execute, then I can put directly the values results, or I can print that one. So it returns, when I call the function greeting, it returns the function, which returns just a string hello, then it takes the name and adds to hello string. As an example, a print function, print, now I say greeting. When I say greeting, I'm calling my function. Already I have the function, I already defined the function, then I am calling the function greeting and I give the value. Because here the syntax says just use greeting and the variables. Now I say greeting and the variables now pop. So if I run this function, if I run this one, the result will be hello pop, because when I call the function for the print is moved to the function, then I have the value Bob, it gives to the name Bob, then the result it returns, or the function returns hello, then assign the value hello Bob. Hello Bob. Okay, now I can run this value and see the result for this, the first function. Now it says hello Bob. That is the output for our function in this sense. Now I move to the second example. In the second example, I want to have some function which takes two numbers, num1 and num2. Here I define, and it adds them. Then I give the function name as addition. So I have def, which is just defining the function, which is the definition. Then defining the function, and now the value, the variable is just an addition. So I want to add some values for this addition. So in addition, I say just the parameters are now value number 1 and number 2. I have two different numbers. Then it takes these two numbers and it evaluates them. Then the result, it will return num1, which gives first number, then plus num2, which takes the second number, and it which is equals to, then the last one, it takes the value num1 plus num2. Then in this sense, then finally I print the results. Just print addition, which calls the function addition. Here we have an addition, then I call the function addition, then it gives the the two numbers. In this case, I use 4 and 7 as an example, num1 and num2. Then I run this function, I will run this one and see the results of this function. Now it takes two values, then the first number is 4, 4 plus 7, it gives 11. That is the output for this function. We can add another just line of codes in, since it is just a summation, I use only just num1 plus num2. But if it is some kind of a complex or some scientific computations, you can add those block of codes between the definition of the function and the return of the results before returning the result. Okay, so if this is just the function, so we can build our own function or we can define our own function. But Python has also its own built-in functions. From the built-in functions, they are so many, but I just put some of them here as an example. The first one is just len, which is len, which returns the length of an object. A list or a string gives the length of a string, or it gives the length of a list, length of a set, length of a tuple. It gives the length. Then the input, this is also a built-in function, which is useful to take input from keyboard, just from the user. Then we have also abs, which is abs, returns the absolute value of a complex number, or simply a number. If it's just a negative number, it gives the positive, it gives the absolute value of the number. We can have the max and min, which returns the largest or the maximum value from the iteration from the list, and also the minimum value from the list. There is also another built-in function, which is range. which returns a sequence of numbers from 0 to the final value we set in the range by increasing 1. Let's say just range. In range 4, which means just 0, 1, 2, 3. In range 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have round, which rounds a number to some specific decimal points. Let's say 3.14578. If I want to approximate with 2 decimal points, it returns 3.14. In the sum, it gives also the summation for some iterations. I will have some examples for each of them to see here. They are other different built-in functions for Python. So if you, for specific applications, for specific tasks, you can just Google the Python page and you will find the built-in functions or the list of the built-in functions. So that's just an exercise for you at this point. Then to use this one, I have an example. I have some list, just 1, 3, 1, 2, 3, and 4. So the first one is just this one. I use the len, which gives the length of the list, which returns 4 in this sense. I will run this one, which returns 4. That will be the result for that one. Then that's the length for. If we want to now the length for a list, we can use len, len. That's just length. The second one is to input. Second built-in function is input. It gives a chance for the user to give an input or the user input. So in this case, let's say user input, or you can say this one is just first name or whatever. That's just the name. So I can run this line and I will show you what it says. It says enter your name and I have space here. I can put here name. It gives space for me to write my name or something. Let's say, okay, John. This is the first name. Then I hit the enter button. Now already the value John is assigned as a first name. Now I will print the first name here. Then let's print this one. It should be hello John, since I already give the value for John. Now it says just hello John because I give the input John as input parameter with the input built-in function. Then it returns the output hello John. It takes the first name from the input from the user. Then the second point is just the abs, which is the absolute value, which gives the absolute value of a number. So I have a complex number 2 plus 4j. Then if I say abs of 2 plus 4j, it takes the absolute value of j, which should be 16 plus 420, which should be just 4 point something. The absolute value should be that one. So I can run this point and see results. Now this is just the absolute value of that point, which is 4.472. I have now this value. Then this is just the absolute value. Then here I have a list 1, 4. Okay, I can make this one. See. 5, let's say 5, 2, 3, 4. Now, first thing is I want to print the maximum and I want to print the minimum. From this list, the maximum is 5, the minimum is 2. So I expect these two values from these results. I will print this one. From the results, now it gives 4. Oh, because after update, I didn't run this one. Okay, I should now. Okay, now see here. I run the minimum and the maximum from this list. The minimum is 2, the maximum is 5. I run it, which is the maximum 5 and the minimum 2. You can see the minimum 2, the maximum 5 from this one. So we can use max and min built-in Python built-in functions to find the minimum from a list and the maximum from the list. Okay, the other one is the range. Range is the function which gives from 0 to the value minus 1 from the value. Then it has an increment of 1 with an increment of 1. If I say for I in range of 3, then print I can run this value. Then the result is it starts from 0 and with 1 increment. 0, 1, 2, and it doesn't include the last point. If I want until 3, this one should be 4. If I want to print until 3, then I can put this one as 4, or if I want until 4, that's just 5. So the last point, the first thing is the last point doesn't include. The second is it starts from 0. The third point is the increment is 1 by default. Now we come to the round Python built-in function. This built-in function uses to round the numbers to some specific or the user specific decimal points. Then I have some value here. Okay, here I have the absolute value of 2 plus 4j, already the one that I printed previously, which gives the value of what this one 4.472. This is the absolute value of 2 plus 4j. Already I have the absolute value. Then this is the number now. From this point I can approximate or I can round the value. Then when I say round this absolute value with 3, this 3 is the decimal point, which means I will have 3 decimal points, which are 4, 7, and 2. The remaining will be removed. So I will check this one. I've run this. Now you see this is just 472. If I say this one is the decimal point to 1 decimal point, that should be 5. Since it is 7, it will approximate this one to up, then the result will be what? 4.5. I can run this one. You can see this one is just approximated to this point. So I can use the round function or the round Python built-in function to approximate the number to some specific decimal points, to some specific decimal points or the user-defined decimal points. We can use the round Python built-in function. The last point that I want to show is sum. So the sum is just, you use to sum the integers or the values given. It could be a float or an integer. I can say just sum 72. The result will be what? 9. It sums to this one. I can also add another point. It's not only 2. I can say as 3 is added, the result will be 12 or 7.0, 7.9, or I can add a decimal point also. It works with a decimal. So the summation works in a decimal. The points could be more than 2, and it sums all the integers given as an input in this sense. So these are not all the lists of the Python built-in function, but these are some of the examples. And the most common ones, mostly we use in our some mathematical operations in some scientific competitions in Python, we use these most common Python built-in functions. And you can also check the other Python built-in functions, and you will learn a lot about this Python built-in function. So if you don't find the built-in function by Python, or if the built-in functions couldn't solve your problem, you could, or you should define your custom function, or you should define your own function to solve your problem or to execute some of the tasks that you are willing to solve. Then this is the way that you could write custom developed or custom functions in Python. Okay, so as a conclusion, this is just the last point for this video. So what I will suggest you is just to practice this of all of the exercises that we go through, and just check again all the values, all the steps, all the concepts we see here. So just understanding these data types allows you to just choose. First one is to choose the right structures, and also understanding the and defining these custom functions also helps you to build some functions to solve your problems or your project in Python. Okay, thank you. This is all about the data types, functions, and also the variable assigning variables for the values in Python. So the next step is just to practice different data types, creating and manipulating them in various different ways for these different data types, and just experimenting by writing some functions, the custom built-in functions, to execute some of the tasks that you have in mind, and also find and use, and also just learn how to use the Python built-in functions is the main points of this series of the video. Thank you. Don't forget to subscribe to the channel, like, and also just share the video to the others. And also if you have some questions or comments, you can put on the comment section. Thank you.